try to recreate Paolo's ring using Grasshopper. First, we'll take a quick look at what he does. Okay. He's setting up, and he's going to use the command flow to surface. He's got a reference surface here and a target surface. He creates the curves that he wants to make, mirrors them to the opposite side, mirrors them again. He's got two reference lines here, so he's got the shank the same on both sides, and he's adjusting it to get it to what he wants the curve to be. He has a circle here referencing the center stone that he's going to use, and then he's adjusting it. He's now flowing to surface to see what it looks like on the surface. He wants to move it down slightly so that it doesn't align perfectly there. Okay, so now he's just adjusting the curve. Once he's done that, he does an offset on the curve, shortens it up in here so that it will flow up there correctly, creates a surface, extrudes it. He goes in, and then he fillets the edges in here to round them up. Then he's going to use these, flow them to the surface here to make the ring shank. Now he's going to create the gemstones quickly and all the cutters, and then he's going to use a flow to surface rigid, align them on the reference surface, and then he's going to bring them into he's going to bring them up onto the other surface. Okay, now that they're moving from here to here, he can mirror them on the top surface there. He's going to add the claws in here so that they show up here. But the whole principle is he's using flow to surface. Rigid and where it flows to the surface and deforms to the surface, morphs to the surface. Okay? In here he's doing the final cleanup on the bottom. He's going to cut those off. He's got the collar set up. He's using a straight claw here. He's checking to make sure they all align right in the claws without seeing the stones. And he's trimmed off part of the ring here. So let's see how this works with Grasshopper. So we have the setup here. The most complicated part of it is the curve. Let's get this smaller here. What we have done is written code. So what he did first is create a reference surface. So we're using a component here that orients it, that we've created. It's called Orient to Ring Surface. This component takes the finger size and flattens it out. It gives you reference lines that you can use for reference. Okay, if you want these lines, you can bake the lines in place. There are these lines here that have been colored. You can see them here as we change the color. Hang on. No, that's the geometry. Yeah, no, that's correct. Oh, that's the ones there. We've done it here. Okay, so you can change them, and if you want to use them to create your first curve, you would right-click and you would bake it. And in our particular case, we would maybe want to bake it here in the crosshairs. So this way, when you draw your curve in Rhino, you can click to these lines, to the nearest line where it intersects. Because what you have to do is create the reference curve. So he creates the first curve here, and that's what we've done. We've inputted that curve here. So basically, as we make changes here, you can see it goes parametric. And the changes are live. Okay? Now, what we've done is created a point here, and we can adjust this wherever we want. We can increase or decrease the offset. We got it at 2 millimeters. So these will be at 2 millimeters. They'll be about 1.9 millimeters. I think he's using around 1.7. That's the right side. The left side we have at 1.92, but we can change that to 1.7 as well. We have a thickness of 1.6 millimeters, so the ring will be about 1.6 millimeters thick. Okay? These sliders here are to adjust the inside loop. So we've created the offset curve here, which offsets this curve here. We've shattered it. We found the curve we want, which is this top curve here. Let's turn this off. See this curve here? And then we're bending between this curve and this curve. These two curves. These two curves are controlled by these sliders here. And then we're bending between the curves here. We're lining them up and joining 1, 2, 3 curves to create the surface. And then we're extruding the surface, capping it, and taking a Boolean difference between this solid and this solid. Between this solid and this solid, giving us this solid. Okay? Now, what we did is copy and paste the whole definition here to this side to create the left side. Then we inputted a left-hand curve. Now you can adjust this as well. Take the control points and move it till you get the shape that you want. So when you see the two parts, we have the right curve, right side, left curve, left side, based off a ring size. Right now it comes at a size 11. We use a bit of mathematics here. Size 11 divided the ring diameter divided by size 11 diameter gives us the scale that we require to scale these curves down so that they fit in different ring sizes. It's a simple trick we use, right, in this particular definition. Now we have the gemstones that are positioned here. You can see we use this gemstone creator to create the gemstones. We then just input the diameter of the stones. We can adjust the claws. Right now we're using a pipe of the extended arcs. We can use the arcs and we can make these into straight lines, because at the final end of ours you'll see that we have little arcs on here. You may not want these arcs because when in the final we're going to delete some of the claws, so the arcs may not be in the right direction. So we can adjust this to pull the arcs out of there. So now we have a much straighter curve. What we do is we get the finished piece here and we put it in a group, and then we internalize the group. that internalized group I've labeled by right-clicking and adding the dimensions. So I know that this group has this gemstone, claws, and seat for a 2mm stone. We're using the rotate 360 because this one is the 2mm stone. That's this one here. So I can adjust that location by clicking on this point and moving the point. So if I want it on the other side, I can easily adjust it. I can also do it this way. I can also rotate it. I can rotate it in the Y. I can rotate it in the Z. So whatever I want to do, this rotate 360 tool we use quite often. From there, we're joining them in a merge to bring all the gemstones together, because in here we've used a mirror for this one and this one. We take this gemstone and mirror it to the opposite side. But because we're not working over 0, 0, we need this line here to make the mirror. This center line here. And that center line we've drawn from further up in the definition here. Okay, the mirror is from a small surface that we've created in here. Right here, you can see it. And we're just creating that surface. It's not being used for anything other than a plane, so that everything we can mirror off that plane. So as we change the size and location of this particular plane, the mirror goes with it. Okay, so sometimes you have to think outside the box. In this particular case, because we're using the tool here, which is orient flow to surface, we need that so that we can mirror to the opposite side without having to manually place it. You can manually place it if you want, so if you don't want this style, but in this particular case, we wanted a symmetry. Okay, and we're putting it in rigidly to the target surface, which is there, and it's going to be bent or rigid, and we're going to go rigid, and we're going with an 8 count. Actually, we have that at 8 count as well. That count really should be the same as these other target surfaces here. So when you change this, let's pull this down here. They always have to be the same, or the alignment's not going to work correctly. So we want to maybe put this in here so that we get an 8 count as well, so that the surfaces align correctly. Then we're bringing it out, we're ungrouping it. There's 7 groups, there's 7 stones and seats. We're ungrouping it, and then we're sorting it out and coloring it. You can bake them in position, and that's what we'll do in the next part. But there you go, we have it described how to make it. Now, the beauty of this is the parametric aspect of it, because now you can go from size 11 to size 7, and everything will change with it without having to make change. When something disappears like that, you have to go back to principle 1 of shake. And what happened here is this point has overlapped itself. So let's go in here, and that's on the right side. That's the right side. Let's take this point here. And there we have it. Now what we can do too is change this location slightly, bring these okay. So this occurs, but you have to understand that we have a mathematical formula here, and that's the Grasshopper definition is mathematics. When something disappears, it just means that our definition is not asking the right question mathematically to show the results. So we have to sometimes just go in there and shake things up a little bit to get something. See here, we lost it again because it's flipped over. And there we come back again. Okay, so there's the setup to make that ring. We have this done. The final steps is Paolo is going to fillet the edges on this. And then we'll float to surface. So let's see what we can do. To do that, we're going to go to the top view. We're going to come in to our definition. Let's bring this here. And we're going to zoom in here. And this green is this one here. So we're going to bake the geometry into the shank. You can see it's been baked. And let's bring this geometry here and bake this geometry into the shank. Okay, let's save this. Let's close this down. So now we have the geometry in Rhino. So technically we can, let's turn off the crosshairs. We can fillet the edges. Type in the command fillet edges. We click on them like he did. And okay, there's one done. Okay, we lost a little twist in here. Control Z. Okay, we're having a bit of a problem right there. Control Z, let's try it again. Let's not worry about that right now. Let's Control Z. Okay, now we have them filleted. Yeah, this worked better in here. We probably have to adjust the curve in here to get rid of that kink, which isn't a problem, but for what we're doing now, let's worry about that later. Recent file, Paolo, okay. Now we want it up on the ring. So what we're going to do is we're going to bring in some geometry, then we're going to click on this, right click here, set one geometry. We're going to bring this geometry, it's there, and we're going to bring it here. Now you can see it show up on the top of the ring in the right geometry. So we'll do that again, but we're going to go copy, CV, copy and paste, and we're going to now right click, set one geometry, and then we're going to bring it in here, and we're going to okay. There we go. So now we can take this geometry as we get it out here and bake it. We have another command running here. Let's bake this again to the shank. There's that 1/2. And we go back up here, bake it again, and we have the other half. Now what we're going to do is go down to the claws, and these have already been put in position, so we're going to bake them, and we're going to put them on side stones, and we're going to take the gemstones and bake them into the side stones as well. Now we can shut this down. But what we should do, if we're going to keep this geometry, let's put this back into place. Let's internalize this geometry so we don't lose it when we close down the definition. Okay, let's save this. Let's clear this. So we now have the geometry in place. Now what Paolo does is we have double claws here. So what you can do, this claw is fine, this claw is fine, but we have double claws here, so we can delete one, and then just bring them into position. Okay, then he takes this and he cuts this in pieces to get rid of the shank there. So we're going to create let's create a curve from the top view. We're going to draw a curve. We're going to draw a line curve. Let's go about here. Select that curve, mirror the curve. Let's draw a line. Join them. Extrude them. Cap it. Move it up. The lean difference from this one, delete this, and There we go. We have the finished ring. Now you notice these claws are curved. His are straight, and we can make them straight in the definition, right? And which isn't a problem. All we do is rearrange the definition slightly. But there's the ring, complete and done. Fine-tuning it is easy. We can lower the gemstones down, lower the claws down in our definition, and we can get rid of these, but we have the seats in place, and the ring is, you know, you can fine-tune it even more. We can get rid of this little error here by adjusting this. So now it's just a matter of fine-tuning it. Now that we got the definition done, let's get Raven to take a look at it. I've asked Raven to explain in a professional, detailed, step-by-step how this definition is made and works. This Grasshopper definition is a professional-grade jewelry design tool specifically built for creating parametric ring shanks with gemstone settings, claws, decorative millgrain. It's saying decorative millgrain because of this component here in the group that makes the diamond accent and claw seat, but there is no decorative millgrain in this definition. The workflow is highly modular, utilizing custom clusters for jewelry-specific tasks like ring sizing, stone generation, and geometric flowing from a flat plane to a curved surface. That's the flow to surface. It's going from this flat plane here to this curved surface here. So that's explained pretty well correct. The step-by-step ring size and reference. The process begins at the ring size cluster, which is right here. The input is the standard Euro or US, standard Euro or US. It generates a ring circle, which is here, which is this circle here. The circle acts as an inner rail for the ring and foundation of the target surface. Correct. This forms the target surface here, which is here. We take the ring circle, we're flipping the geometry, we're moving it from one side down and to another side and flowing between the two sides. So we're flowing from this side to this side. So we have the two geometries, which is this curve and this curve. Okay? The shank, profile construction. The script builds the ring's metal body, the shank, using profile-based approach. Profile logic. It takes the base curve and uses offset curve to control the thickness. So what we're doing here is using a left curve, that's this curve here, mirroring it to this side here. We create the curve, we're mirroring it to the opposite side, lofting it. Mirroring the created closed curve to represent the cross-section of the ring. The profile is extruded and capped. Okay, we have the base. Let's turn this off. Let's turn this off. Okay, we're extruding. There's the opposite curve. We're extruding this curve and capping it. And then we're bleeding the difference from the center. So we're cutting this hole out of this big lollipop. Okay. And we're doing the same on the opposite side. So we have a right side used for the right side. We create this curve. We mirror the curve. We close the curve. We extrude the curve up, cap it, and then we find this curve, extrude it, cap it, and Boolean difference for the left side and the right side. So we're using the left side and the input curve on the left side, right side. After that, we're using flow to surface. We're taking the geometry. Okay, let's get ahead of ourselves here. Okay, we're mirroring, creating this up. It essentially creates the ring unwrapped in a flat XY plane before it is mapped to the final circular shape. Correct. The parametric gem generator. We're using this definition found under settings, 36 clause with seat, bringing it down. We're creating the seat for the gemstones by size. We're grouping the gemstones and the parts to the pieces into a group. We're internalizing the group, the gemstone mesh and the parts, and internalizing them. Okay. You can select oval, round, XYZ dimensions. Simultaneously generates three things: the mesh, the girdle, and the solids cutters. It also creates cutters in here too. Under here we have gemstone cutters if we want to use them, but we're not. We're creating a seat right here using a extrude and difference. Because we're internalizing each, we don't have to make multiple copies of this. We just increase them and then load them up. So we got a 2 millimeter, 1.8 millimeter, 1.6 millimeter, 1.4 millimeter. Okay, the setting details, the secondary, they're describing this section here. All right. Secondary clusters, highly detailed decorative function, blah, blah, blah. Arc from 3 curves, that's this, for creating the claws. Then it goes into the claws as a pipe. Okay. The positioning is the flow to surface. This is the core trick of the definition. The global positioning and rotate 3 allows you to position the stones in the settings. This allows you to position the stones here by moving this. You move them on the 360. Okay. Global positioning, rotate, move 360. The surface mapping is the orient to ring surface cluster, which is this. We're putting them in groups, mirroring them, bring them down into a merge, so we have all of them together. Then we're orienting to the target surface, and we're doing it rigid. Once we get that out, we're ungrouping it, and then we're sorting and displaying it. And that sorts and displays this on top. And there we go. The definition with a sort by geometry type. This organizes the complex output into a list like meshes, B-reps, curves, etc., etc. This definition produces a fully parametric ring by changing a single slider. You can jump from size 6 to size 10, which is true. We can jump from, right now we have it set up in a size 11. Because we have included this scaling factor in here, we can, right in here, we can use this now to change it to any finger size and everything. Okay, when you see it disappear like that, that's the left side. Left side. Let's pull this in a bit here. And you see it come back to life. Okay? Remember, sometimes you need to shake a definition to get it to produce out properly. So this is Raven. You can stop and take a picture and read it in more detail, explaining the use of this definition. Thank you for watching.